Okay, welcome to video lab number 9, which is the Super Bowl video lab. We'll find out what we mean by that a little bit later, okay? Let's meet our team today. What would your name be, Miss?
Trisha.
Okay.
Joe.
Jesse. Evan.
Okay, very good. Who can tell us from the class, what's this lab all about? What is it?
The density of water.
Very good, Liam. This is the third and last of our density labs. Now, we've done 2 other densities besides water. What's one other thing we were trying to figure out?
Density of wood block.
Yes, and what's the other thing we were trying to figure out?
Metal.
Yes, okay. Now, it doesn't matter what we're trying to figure it out. When you're doing density, you still have to know 2 things about the object. What's one thing that you have to know?
Volume.
Say it loud.
Volume.
And the other thing? Mass, okay? All right, so today we're going to figure out the volume and the mass of some water. But what's the problem if you're trying to weigh water?
You can't stay in one place in the pan.
Yes. So how do we solve that problem? Yes. Put it into a container. Okay, who's got the container? Hold that container up so we can see. What do we call the container that Joe's holding up?
Graduated cylinder.
Okay, so now tell me, how are we going to get the weight of the water in that cylinder? What do we have to do to figure out its weight? Lee,
Fill the water up and put it on the scale.
say what?
Fill the water, put the water in the cylinder and put it on the scale.
And that will give us the weight of the water? No,
Oh.
not quite. Yes.
Sorry.
You have to subtract the weight of the container and the water.
From? There's 2 things that when you're subtracting. You only said one thing.
Okay, wait, never mind.
You have to weigh the empty cylinder and then weigh it with the water in it and subtract.
Okay? You need 2 things. Okay. So now that we know how we're going to do this, why don't you weigh the empty container to begin with, and we'll just check out the class while we're doing this. Too late, we got you.
I know.
Future of America right here. Boy, are we in trouble. Okay, what you got, Joe?
25.3.
Okay, now you're going to have to remember that number, because, excuse me,
What happened?
not a lot for you. You're going to have to remember that number because we're not going to write it down. So what was the number?
25.3.
Okay, just keep remembering that. Now, what's the number?
25.3.
Just checking. Okay. Patricia, you're going to take that cylinder, you're going to head to that sink and put any amount of water that you want, and we'll go with you and see what things might take place. So any amount will do. Inadvertently have hit the date button on this as we're doing it. So just put in any amount, Patricia. It's okay. Just bring it back. And while we do this, I'm going to shut this off for a second. Hi, Patricia.
Hi.
Okay. Could you tell us, by holding it up at eye level, how much water do you have in there? Got to hold it level when you do it. Bring it up to your eye. And now, tell us, how much water in there?
3.0.
How much?
3.0.
3.0. If you would write that down next to milliliters, 3.0. Okay, now you're going to weigh it up again so we can get the weight that's in there. And what'd you get?
28.3.
28.3. And what was the other number you had to remember?
25.3.
Okay, and if you would subtract those 2 numbers and tell us what did you get for the weight of the water in grams?
3.
3.0, right? Okay, would you write down next to grams, 3.0? And Evan, then just turn around at this point so we can see what you've done. We're going to be figuring out 2 different densities this time. One of them is in milligrams per milliliter, and the other is in grams per liter. And in order to do that, we need 4 bits of information. And at this point, we only have 2. We have the milliliters and the grams, but we need the liters and the milligrams. And so the class is going to help get the rest of that information. We want to change milliliters into liters. Mathematically, what do we have to do to make milliliters into liters?
Divide by 1,000.
Yes, and why are we using the number 1,000? What's the relationship that has us use that number?
No.
Okay, who can help him?
There's 1,000 milliliters in a liter?
Yes, okay? So you told us there was 3.0 milliliters, and now it's time for you to do this in your head. There's 1,000 on the outside, there's 3.0 on the inside, and you're going to divide, okay? Do it in your head. 1,000 into 3.0, what is the answer? Uh-oh. Yes?
0.003.
Yes. If you would write that next to liters, 0.003. Okay? Our next conversion takes us from grams into milligrams. Mathematically, what do we have to do to get grams into milligrams? Yes? Multiply by 1,000. Why are we using the number 1,000? What's the relationship there?
Oh, never mind, sorry.
There's 1,000 grams in 1,000 milligrams in 1 gram.
Yes, in 1 gram, okay? And the number that you're multiplying is 3.0. In your head, it's fairly easy. 3.0 times 1,000. How much is it?
3,000?
3,000. So if you write down 3,000 milligrams. Okay, now, you have the weight and you have the volume. Mathematically, what do you have to do now to get the density? Yes.
Divide
What?
the volume by the weight by the volume.
Yes. Okay, and that's where you come in. You're going to be doing 2 divisions for us right now. So I want you to plug in the milligram, milliliter numbers and tell us what's the density in milligrams per milliliter.
1,000.0.
1,000.0, if you would put that down. And then if you would plug in the grams and the liter answer, tell us what's the density in grams per liter.
1,000.0.
And if you would put that down, and then turn around what you've done, so we can see the results of your work. Okay, the first thing we notice here is that the numbers are the same, both 1,000. The units are different, milligrams per milliliter, grams per liter. Let's talk about those units for a second. 1,000 milligrams per milliliter. What is 1,000 milligrams equivalent to in the metric system? It's the same as saying what? 1,000 milligrams is?
A liter?
No, 1,000 milligrams
It's a gram.
is a gram. Okay, so a gram is equivalent to a milliliter. Okay, it also says 1,000 grams per liter. What is 1,000 grams equivalent to?
Kilogram?
Right, so a kilogram and a liter are related. What's the ratio of all those numbers that relate them? 1 to 1. Okay, so what that means is there is an establishment now, or a relationship in the metric system between weight and volume. So if I tell you the weight, what do you automatically know? If I tell you the weight, the volume. And if I tell you the volume, what do you automatically know?
Weight.
But it will only work with one particular liquid, which is water. Okay? Now that you understand that 1-to-1 ratio, we're going to do something now. I'm going to shut off this camera in a couple of minutes, go up to the front, and I'm going to take some objects, and I'm going to throw them at you. You have to catch the objects. If you don't catch the objects, you get hit with the object. Okay, that's why it's called the Super Bowl lab. I'm going to throw you some passes. Don't get nervous. Okay. When you catch this object, if you look on the object, it's going to give you, somewhere it's printed, a metric volume for that object. Okay, you can tell the class what the metric volume is. And then, based on this 1-to-1 relationship, the class is going to tell us how much would the water weigh if it filled up that object. Everybody understand what we're going to do now? Okay, now, I'm a righty. And my right hand is attached to the camera right now, which means I'm going to throw in my left hand, which means it's not always going to go where I want it to go. So you have to be ready for this. I might say I'm throwing it over here, and the people over here might get hit in the head. Okay? So don't just sit with your hands folded. Get ready to catch it. All right? All right. Shut it off and be back in a second. All right, now, first object that I'm going to be tossing at you is this object right over here. I'm going to toss it over there, which means you guys over here better get ready. Sort of like the Mr. Model pass. If I throw it this way, it probably goes that way instead.
What if you don't?
You know what I'm talking about? He looks this way, talks that way. You! Okay, here we go. Danielle, if you're sitting like that, you're going to get hit in the head. Are you ready?
Blue 41.
Good catch, Danielle. Now, read the bottle. It has a metric volume on it. How much does that bottle hold? No? 1 liter. If that bottle was filled with water, how much would the water weigh? Liam? 1 kilogram, because the relationship is liters and kilogram. Do you remember how many pounds a kilogram weighs? 2.2. So in other words, if that was filled with water, it would weigh over 2 pounds because of the water that's in it. Okay? So we're going to continue now. Next object. Okay? It's going over here. So get ready, guys and girls. Okay, good catch. Would have knocked Anthony totally out. Nicole, what's the metric unit on it? Say it loud. 354 milliliters. How much would the water weigh in that container? Yes?
354 grams?
Yes, because the relationship is grams and milliliters. Okay. Next object is coming to the middle. I'm not sure if it's going to go to the front or the back of the middle. There's the object. Okay? So here we go. Get ready for it. Carrie, are you ready for this? Okay, here we go.
Oh, yeah, there you go.
Joe, what does it hold? 2 liters. How much would the water weigh that's in it? 2 kilograms, okay? Next one, coming this way. Okay? Here we go. Ready? Danielle, don't hold your hands like that. A dropped pass. Pick it up, pick it up. Okay, Anisha, read it carefully. You're looking for the metric unit on it. Can't hear you. 473 milliliters. How much would the water weigh? Yes.
473 grams.
473 grams. Okay, next one's coming to this side. Okay, here we go. Okay, Liam, how big? Big words, right, in the name of it. They never find this, and it's like huge.
3 liters.
That's it. How much will the 3 liters weigh? 3 kilograms. Okay, you seem to have gotten the idea of what this is all about. Now, you realize why we call this the Super Bowl lab. I've been throwing passes to you, right? We always do this lab right before the Super Bowl, and the Super Bowl is this weekend, and the Giants are in it, right? All right, now, how many of you have ever played football before? How many of you think you're so good in football that you could be on a Super Bowl team? You could catch a pass. Joe, you think so? Joe, get up. Back up over there into the space. Patricia, move to the side a little bit. Okay, Joe, here's what we're going to do. Only Joe can catch this. You understand that, Jamie? Because I'm reading your mind right now. All right, we're going to throw Joe the pass. The Super Bowl pass. Joe, if you catch this pass, we have a full week's vacation for you, all expenses paid, in Poughkeepsie. If you miss this pass, Joe, you will have to spend 2 weeks in Poughkeepsie. Get it?
Okay.
Okay, here we go, Joe. Are you ready? Okay. Remember, I'm throwing it with my left hand now. And he caught it. Give him a big hand. Way to go. And this ends video lab number
9.